And that one you get. All right.
Did he die?
Did you just actually, literally LMAO yourself? You laughed yourself right off your A?
I did that so many times. Very sick.
All right. You guys already understand the coordinate grid because, of course, you know how to play Battleship. For some strange reason, the coordinate grid is baffling to people. The thought that you could possibly understand right and up being positive and left and down being negative is apparently somewhere in the neighborhood of actually understanding the physics behind virtual atoms. Virtual atoms are theorized particles of matter that can change what they are randomly. They have been theorized about for about 50 years, and they have recently been possibly actually seen. With a super powerful telescope looking at a star 400 light years away from us, they think they have seen matter, virtual matter. Which means technically, if those things do exist, you could possibly put down your cup of tea, look away, and look back, and there would be a pineapple.
I don't like a pineapple.
That won't happen. I'm just saying. Like how when you put your keys down somewhere and you walk away and you look back and they're gone, and then you look for them somewhere else and you come back in the room and they were right there where you always left them? Yes. All right. So apparently the coordinate grid is utterly baffling to the average man on the street. I lie, the average person on the street. Of course, it is not baffling because it is incredibly simple. All right? From now on, and for the rest of your time in math, you will see the following construction. That construction will look like this. You will see a bracket. You will see a number. You will see a comma. You will see another number. Then you will see a bracket. That always, when? Always. How often?
Always.
When again?
Always.
Means the same thing. It means that you have what we call coordinates. Those coordinates are used in every field of endeavor that humans undergo. They sometimes use them in different ways, but the method of use is always the same. And they are always written as X and Y. X is always horizontal. So the first number always moves you left or right. To the right is positive, to the left is negative. Y moves you vertically. Up being positive, down being negative. If I had these coordinates on a map, up would be what? No. On a map, up would be north, and down would be south. And at positive X would be east. Negative X would be west.
Kanye West.
What about Kanye loser? And we'll just end the discussion now. Okay. All right. Apparently, that's difficult. Now, I'm going to give you guys a couple of other things. The coordinate grid has another name by which most of your future instructors are going to refer to it, because for the past 300 years it has had this name. But because it was named after a European male, they don't like to give that guy credit anymore, because it's not sexy to give credit to Europeans, because it's not politically correct. So this thing is also called the Cartesian plane, because it is named after René Descartes, the famous French philosopher who said, "I think, therefore I am." Of course, he was not English, so he did not say, "I think, therefore I am." He said, "Cogito ergo sum," which is Latin for "I think, therefore I am." Being French, he also would not have said, "I think, therefore I am." He would have said, "Je pense," some other word that means therefore, and then "je suis." But it doesn't matter. Ironically, that saying has been used wrong for the past 300 years, because as always, people took "I think, therefore I am," and that's the only part of the saying that they think about. And, "Oh, I think, therefore I am." It doesn't mean that. It's actually way deeper than that. But that's beside the point. That's for history or philosophy class, not math. But if you find yourself at university with nothing better to do and a course to fill, I recommend a course on philosophy. Because the more you people know about the way we think, the better off you will be. Even though it really holds very little value monetarily speaking. Mr. Anderson? A philosophosaurus would be my guess. Oh, okay. All right. So, you guys are aware of this situation. I would like to discuss the parts of it now. Who knows what that point right there is? That is called the origin. It has coordinates of 0, 0. You have not moved left, neither left nor right, nor have you moved neither up nor down. So you are at 0, 0. The coordinate grid is divided into 4 parts. Those 4 parts are called quadrants. We call them quadrants because quad, for 4. There are 4 of them. This is 1. This is 2, and I will label them. This is 3, and this is 4. 1, 2, 3, 4. It is always in that order. Quadrant 1 is quadrant 1 because every coordinate in quadrant 1 is positive, positive. Quadrant 2 is what? No. Negative, positive. Quadrant 3, negative, negative. And quadrant 4, positive, negative. Yep, because you always do X first. Is everybody cool? Excellent. Now, let us make sure you can actually read these things, because I know you can play Battleship. What are the coordinates of A, B, and C? Go diddly O. I used to have a student that would get mad at me when I took a sip of hot tea and went afterwards, because she figured that you should only say if it was a cold drink. I don't know. That girl made a point of arguing every single thing I could possibly have done. The sun is out today. No, it's not. The lights are off today. No, they aren't. I know. I have a Christmas ornament pierced through my ear. No, you don't. That's what she was like.
Was she obnoxious?
Extraordinarily.
Like she wasn't even kidding, that's actually what she did.
To the point of, I just assumed that she was a generally hateful person and hated me. I taught her when she was in the 10th grade, science. I never taught her again, but every single day she would come to my classroom and visit. For all of grade 11, all of grade 12. After grade 12, she would come back and visit. I never understood it. What did I just say about her? She was phenomenally obnoxious. And yet, I had to put up with her daily. Yes, she was fairly intelligent as well. Intelligence does not negate obnoxiousness, nor does obnoxiousness negate intelligence.
So did you just pretend to like her? Did you tolerate her?
Well, I don't really have a choice. It's public school. What am I going to do? Get out?
When she came back to visit you, were you just oh, hey?
I'm not a dink, Taylor.
I know.
I said hello and acted as if I cared about what she had to say. But I could not have cared less, Taylor, because no, I did not like her.
There you go. That was
Not even a little bit. Because she was mean. I don't like mean people. What? Of course I will.
Would they be good or bad?
You people, not you people, but students are all of my material. One day I will tell a story. I used to teach this kid. He was like the smartest kid I ever met, but he didn't even get knock-knock jokes. I will tell another story about I used to have this kid. He would never, ever shut up. All he had to do, there had to be noise coming out of his mouth. Sometimes he would just sit there, because he couldn't think of anything to say. I will tell another story about I used to have this kid. I'd give him a question like this: 7 plus 2 equals blank. And it would take him an hour and a half. He would write 9 in 1 second. But then for the next 5,399 seconds, he would be double checking. I will tell the story of the kid that sat in the front of the room and would never ever get glasses. And how one day he stole my glasses right off my face and then walked out with them. I will not tell them that I was wearing contacts at the time. I will let them think that I went home blind, because that's funnier. And none of you will be here to defend yourselves. I won't use your names, just like I did not use this young lady's name. I usually don't even narrow it down to a gender. But I will tell these stories. Be aware. I will tell the story of the girl I had in grade 9 that every so often I would forget to make a key, so I would use her test. I will tell the story of the kid who never got the jokes but somehow managed to actually laugh his A off. So, back to business. What are the coordinates of point A? -5, -4. Lovely. What are the coordinates of point B? 3, 5. What are the coordinates of point C? 2, -5. Excellent. Now, put an X there, put a dot there, and put a lightning bolt there. Guide the red dot as if it was with your mind.
With the dot or the X?
Where must the red dot go to put the X? No! Guide it, Taylor.
Guide what?
The red dot.
Left.
Okay, guide it left.
How far?
3 spaces.
1, 2, 3.
Excellent. Now put it there.
Uh-huh. And then do what?
And then you leave it because you don't have to.
Absolutely right. You draw your X right there. Lovely. Mr. Anderson, guide the red dot to its black dotty home.
So you must move to your right 4 spaces.
What?
No, I did it wrong.
Mr. Anderson, fix it now.
You move 2 spaces to your right, and then go up 4 spaces.
Excellent. And we put a black dot. Guide me to the lightning bolt, Miss Horner.
Go down 3 spots.
And then draw a lightning bolt.
Okay, Connor.
All right.
That's actually a pretty nice lightning bolt.
No more horse pucky. X's are first, Y's are second. Now, thinking back to yesterday, we have a relation. That relation has an unknown. That unknown is n. Is that n the independent or the dependent variable? Why is it the independent variable, Mr. Leighton Verriger?
Roger.
Yes. You cannot get your dependent variable until you do stuff to your independent variable. So n is my IV, and it is also what I like to call my input, because just like on a computer, it will do nothing until you tell it to do something. This equation, this expression will do nothing until you give it a starting point. That starting point is n. Now you guys are smart people. If I must start with my independent variable and x's go first, and n is my independent variable, where on the chart should I put n? Here or here? Left or right? Left. Which means my n's are graphed on what axis? The x-axis. So even though it is an n, we will put it on the horizontal axis, which makes 2n plus 1. My dv is my dv or my output. Okay? Okay. So, if this is my input and this is my output, then what are the coordinates on this graph associated with this input and output? They are 1, 3. So I would go 1 and up 3. What's the next point? 2, 5. So I will go out to 2 and up to 5. Now hopefully you are noticing that 5 does not exist on the graph, does it? But it is exactly halfway between 4 and 6. So where do I put the dot? In the middle between 4 and 6. What is the next point? 3, 7. And the point after that, 4, 9. And the point after that is 5, 11. Everybody cool? And then, of course, we would connect the line. Because no matter what number I put in for n, I will get an output, won't I? If I say n is 4.1, can I do 2 times 4.1 and add 1? Will I get a number? So I make a line. Got it? All right. You guys graph that in first. What are the 4 points? 0, 2, 1, 5, 2, 8, and 3, 11. 0, 2, dot, dot, 1, 5, dot, 2, 8, dot, 3, 11, dot. Now, think about what I just said. Do I connect the line?
Yes.
I will give you a hint. Amy has shaken her head. Do any of you wish to change your vote?
Yes, it's not. Yes, it's no.
All of a sudden, every vote changes.
We know Amy's smart.
There is one person that shook his head. Blake. Blake. Because now you know that Amy is shaking her head, so it's obviously right. Why did you shake your head? Oh, right answer, wrong reason. But that's okay. You had guts to stand up in front of everybody going, yes, of course you joined the line. You're so stupid. Of course you joined the line. Why do you not join this line? Leighton, what's your guess? No. No. What is your output if I input 1/2? Do you know? You do not know, do you? Could this graph do this between every point? Could it? So can I join that line? Of course not. So 1, I can't join the line because I have no input data between 1 and 2. For example, how is that different from this one where I did join the line? No, it's got nothing to do with where it starts. You have an expression. You know that whatever you input, you multiply by 2 and add 1. So you can find every output. Can you do that here? No. So then the question becomes, is it a linear relation? I am not drawing a line. Is it a linear relation? Think about what we did yesterday. What makes something a linear relation? Because you all did all your homework. I know, that's the smile I have too, Michael. It's called a Cheshire Cat grin. I know. That's why I'm smiling too. Because I know there is nobody in the room that will answer this question correctly. I'll wait a moment while I drink some more tea to bask in my glory. Is it a linear relation? Because we spent all yesterday describing linear relations. Absolutely correct. Yes, it is linear because when I go 1 that way, I go up 3. 1, 3. 1, 3. Plus 3. Plus 3. Plus 3. Plus 1. Plus 1. Plus 1. Why is it a linear relation? Because the change in IV always results in the same change in the dV. So every time I go 1 to the right, I will go up 3. What if I go 2 to the right? What if I go 3 to the right? What if I go half to the right? What if I go 1 left? Down 3, Mr. Anderson. Well played. Nobody saw that coming. Way to go, buddy. Yes. Yes. Bask in your own glory for a moment. There you go. Good job. Good job. All right, all right, all right. Let's see if you can put it all together. A photographer charges $40 for a sitting fee plus $20 per sheet of prints. You can tell how old these notes are. Who goes to photographers anymore? All right. So, in order to make an equation for this and to graph it, we must have an independent and a dependent variable, correct? What is my IV? What is my dV? Talk amongst yourselves until you figure it out. Do not yell out an answer. I am going to wait a moment, Mr. Nyer. All righty then. What are the two variables, Mr. Anderson? Give me one of them. The dV would be the sheets of prints. That's what Mr. Anderson has decided. Do we agree? No, it cannot be, can it? Why? Leighton. Cost depends on how many sheets you order. Right? You are a handsome man, Jack. If you go into the photographer, obviously you're going to order many sheets of prints because you're so gosh darn good looking. But if somebody who doesn't want pictures goes in, gets the picture taken and says, yuck, they are not going to order as many prints as you, so therefore their cost will be less. Understand?
Yeah.
So the independent variable is the sheets. The cost is the dependent variable. So, in our chart, what goes on the left? The independent, the IV, or the input. Right? Or the thing we are going to put on the x-axis, which in this case is S, which equals sheets. What will be over here? The DV, the output, the y-axis, which we have decided is cost. Yeah? Yeah. If I order 0 sheets, how much am I paying the photographer? $40. Because he had to set up the lights, he had to book the appointment, he had to get all his stuff together to take pictures of you to make you look pretty. Yes? If I order 1 sheet, how much do I pay? $40 plus 20 times 1. Because I only ordered 1 sheet. What if I order 2 sheets?
40 plus 20 times 2.
What if I order S sheets?
40 plus 20 times S.
Yeah?
Yes.
Yeah. Graph it. I've already given it away by putting the N and the C in their spots. I'm a nice guy. Yes. I must have used N at some point instead of S for number of sheets or something stupid like that. Aight. Who decides where to put the numbers on the graph? You do. I'm going to put them at 1. 2 squares is going to equal 1. 2, 3. Cool? Who decides where to put the numbers up the cost side? You do. I'm going to say this first dot is 20, which means this dot must be 40, and the next dot must be 60, and so on. I put my first dot at 0.40, because if I order no sheets, I pay $40. Yeah? When I order 1 sheet, what do I pay? $60. When I order 2 sheets, what do I pay? $80. When I order 3 sheets, what do I pay? $100. Do I join the line? Well, let's think about this. We have an equation. Cost equals 40 plus 20s. Or n, or whatever we're using, right? So the last 2 examples, the first one we said, yes, you join the line because you have an expression. You can always find out the output, yeah? The second one we said, no, you cannot join the line because you only know inputs and outputs at those points. Well, now we know inputs and outputs at those points, and we have an expression. What a poser! Do we draw a line or do we not? Amy, do not say anything. Make everybody else vote first. Do I draw a line or not? Amy, do I draw a line or not? Do you think?
Yes.
Amy goes with yes. Are you all going with Amy?
Yes. I'm gonna change. I'm starting with yes, but I want to be no now.
You're going with no?
Yeah.
Why?
Because I don't want to be the same as everybody else.
That's a silly reason. Sam.
Thinking no, because like basically
Okay. Going once? Going twice? Going thrice? We do not join the line. Why? You cannot order half a sheet of prints. So is there an output for half a sheet of prints? No. Can you go to 7-Eleven and buy half a Slurpee? No. You can buy a Slurpee and fill it halfway, but you are still paying for a full Slurpee. Can you go to the gas station and say, "Excuse me, Meister, I would like to buy half a tire"?
Yeah, let's do that.
We're having a 2 for the price of 1 deal. 2.5 times for the price of 1.
Can you go to the grocery store, to the clothing store and say, "I would like to buy a pant"? Get it? Pair of pants, a pant, one leg. You cannot buy a pant. You must buy 2. So, again, it is yet another example of when you must not It is yet another example of when you must stop and think of the situation in which you find yourself. Do not learn rules and shortcuts. Learn what is happening at the time that you are working. Understand? Okay, so this is something that we call discrete data, because it is not a solid line. You cannot have a fractional input and fractional outputs. However, is it still a linear relation? Yes, because every time you add a sheet, you pay $20 more. Does everybody understand that?
Yeah.
Okay? Now, in this little box here, we're going to write out what I just told you. Linear relations. Oops, not linear relation. Linear relations graph as straight lines. However, if we cannot have fractional inputs, we cannot join the line, because that is when we have discrete data. Does everybody understand? I'm going to give you a different example. I jump out of an airplane. I haven't yet. I plan to skydive soon. Yes. I jump out of an airplane. You, on the ground, are timing my fall. All right? At 0 seconds, how far have I fallen out of the plane? 0, because I haven't moved. You then count 10 seconds, and you see that I have fallen a certain distance, yes? You then count 20 seconds, and I have fallen another certain distance, and 30, and so on, yes? You have data for me only at 10, 20, and 30 seconds, yes? So on that graph, how many dots can you put on it? 3. One at 10, one at 20, one at 30. Can you connect that line? Again, do not listen to your shortcuts. Think about the situation. Do I jump out of the plane, disappear, and reappear 10 seconds later? No. So for all of that time, between 0 and 10 seconds, do I have an altitude? Do you know it? No, but you know it's there, so you connect the line. Do you understand? All right, now, all of you, close your eyes. Be honest, close your eyes. I am going to move a certain amount to your left. Okay? Everybody ready? Don't look.
What are you moving? Yourself. The chair.
Now, open your eyes. You now have me at -3 steps from where I started, yes? So I would have a dot at 0 and a dot at -3. Can you connect those dots? Yes, because I had to go that distance. I did not apparate from there to here, like in Harry Potter. Okay? Use your brain. An apparatus is some sort of contraption built to do something. For example, this desk is an apparatus to hold your work on. Everybody understand? Now, if this was Star Trek and I was over here and I said, Scotty, beam me 3 paces to my right. Close your eyes. Open your eyes. Did I occupy any of that space? No. So would you connect that line? No. Got it? Excellent. Thank you.
Oh my God.
Oh, I want that.
Everybody wants a lot of stuff I have, Leighton. I'm used to it. All right. Let's see if we can do it. Go. Graph that data or data. Then decide if you're going to join the points, why or why not. Then tell me if the relation is linear, why or why not. And then describe the patterns. On the left, X or Y? X. On the right, X or Y? Graph them. Down here is my number. Up here is my cost. Who decides where to put the dots? You do. 1, 2, 3. Do I need to continue labeling? Do I need to label anything more than one spot, really? If I only put a 1 there, you know every square is 1 going that way, yes? Excellent. What am I doing going up? What should I go up by? 10? All right. 5s? All right. 5, 10, and I'm done, right? Now, where does my first dot go?
It goes on the 1 and 4.
Which is where? Up how far? 4. Where's the next dot go?
Up 1, then 1 to the right.
1 right, 1 up.
1 right, 1 up.
1
right,
up. And I stop there because that's at 4, yes? Graph the data. Done. Is everybody happy with our graph?
Yes.
Is it correct?
Yes.
100%?
Yes.
You're willing to bet your grade for this section of this unit on it?
Yes.
You are telling me that is 100% correct.
No. Maybe second guess yourself.
I know I'm making you second guess yourself. It's pathetic. Are you guys right or wrong?
Yes.
Of course you're right. Don't be wusses. That is correct. The graph, the data is graphed. The data is graphed. Do we know if the graph is complete or not? No, because then we have to talk about B. Should the points be joined? Yes or no? No. Why not? Justin? You give him a dirty look, Justin, because I didn't say Sam McCarr. I said Justin.
Can't buy half a DVD.
You cannot buy half a DVD. You can try. Hey, Walmart, I only like half of Star Wars The Force Awakens, so I've broken the DVD in half. I'd like half my money back, please. Right?
Yeah.
It doesn't work.
I only want to use half movies on Netflix, so
Exactly. I only watch one movie a week, so I shouldn't pay $7.99 like everybody else. Is the relation linear? Yes. Why? Goes up by $5 for every one DVD. Now, question D seems exactly like question C, doesn't it? But it's not, is it? What is the answer to question D? It's not $20. You pay $20 to join the club.
Oh, okay.
Then your DVDs are only $5 each. $5 for a DVD is not that much. Because if you buy one DVD for Star Wars at $15 from Walmart, 2 DVDs is $30, right? For these people, 2 DVDs was $25. So it's a better deal, isn't it? Excellent. Carry on. So, guys, this explains the relationship. Does it explain the pattern of the graph? No. What is the pattern on the graph?
One rate and one off.
Right. So, the patterns on the table are right here in blue, correct? That's the patterns in the table. But on the graph, because we set the graph up on a different scale, on the graph, it's one right, one up. Because the up is in $5 increments. Do you understand? Even though we only went up one square, we actually went up $5 because the graph is not real life. Okay? I think you're lying. Do the next one. And I'm not going to say a word until it's time to discuss whether or not we are joining points. Go diddly oh. I will be right here doing Grinchy fingers. Yes.
I didn't hear what you said. I said
No, the Grinch stole Canada Day.
I hate Canada. It's so boring.
Why?
It's so boring because it's
Isn't very boring.
every
Grinch
day.
stole Canada
Or
Day.
every year.
What are you gonna do? Go around and steal all the Canada plates?
It's every year it's the exact same thing.
You're the
And
exact
that's
same
not
thing.
monotonous.
This is actually pretty fun.
Okay.
I don't understand how this is fun.
1, 5. 2, 8. 3, 11. 4, 14. Is the data graphed? 100%? Excellent. Is it linear?
No.
Yes.
Oh, man.
Why?
Does it go? Put my hand up. Can I go up?
Goes up 3 meters per floor.
And it goes side one.
Excellent. Good. Lovely. C. Should the points be joined?
Yes.
No. No. No.
Yes.
No.
Yes.
No.
Yes.
No. Be quiet. Stop calling. No.
It's still going all the same height though.
Stop.
I think.
Building.
Yeah. Same.
Window washer. Right?
No.
Window washer washing this window. Is he at a height on the building?
Yes.
Does the window washer disappear and reappear at the next floor? No. Does the window washer have an altitude everywhere he goes?
That's so cool.
So is there an output of altitude no matter what his input? Yes, there is. Same thing. You are not disappearing. You are passing between all those altitudes. So in this case, we do connect the line. Why do we connect the line? Because there's an output. And what is the output in this case? Height for every possible input. Right?
0.1.
Yes, if I move 1 centimeter up on my window washer rope, I am 1 centimeter higher. If I move a picometer up, I am 1 billionth of a meter. Once again, think about reality. Okay, now all those are real, right? They work all the time. The bell's about to ring. I'm going to stop right there. You're off the hook for homework because this has been slightly more difficult than you probably would have thought it was.
Thanks. Got a report to do.
Yes, I hear there are French projects and things that need to be done.
Sucks.
Mais oui, la langue de l'amour. Yeah. Oh, I didn't hole punch those, did I? What?
They keep teasing me about stuff.
Do you care?
I know.
Really? Are they your buddies?
One.
Are they your? If you were in jail in Mexico, Justin, would you call any one of those guys to come and save you?
No.
Yes.
Then why do you care what they think? The only people you should care about what they think are the people who would come and save you from a Mexican jail.
I would, Justin. I'd bring
Okay?
I'd bring
And that includes all the idiots you know on Facebook.
I barely use Facebook.
Justin, that's not the point. The point is, if somebody said something bad about you on Facebook, you would be like, well, they said it on Facebook, and you'd be all sad. You shouldn't be. Okay?
Why would you be the Mexican too?
Why would you like
I'm a good boy.